Okay, close already. I thought why cannot close. Okay, now after going through the frictional force, now we go on to tension force. Tension force is actually the force that is transmitted along a string or a rope. One more time. Tension force is the force that is transmitted along the rope there. Let's say you pull the rope and the rope is attached to an object. You're
Okay.
actually pulling the object. But how is the force transmitted to the object? It is through the tension in the string. Now, whether the string has tension or not, you look at the condition of the string. If the string is taut means straightened like that, then there is tension in the string. Let's say if the string or the rope is slackened that means it's slackened, then there is no tension. So whether there's tension or not, you see whether the string or the rope is taut or in the slackened state. Okay, then you know whether there's tension or not. Okay, so we look at a few cases of tension in a string or a rope. Now the first case is like this: an object attached to a string and it is hang onto the ceiling. Something like this. This is a piece of stone. The stone is tied to a string. The string is hanging above, this hanging on the ceiling there, right? Okay. Now, if you look at the object, don't look at the ceiling lah. Don't look at the ceiling. We look at the object, the piece of stone in Africa. Now, when we look at the object, there are two forces acting on this object M of mass M. One force is the tension in the string. So don't think that the string has no force. The string actually has a force that is pulling the object upwards. So the force in the string is called tension and it is acting upwards. The second force acting on the object is the weight that is acting downward. Now, since the object is in equilibrium, that means the object is not moving, accelerating upward, accelerating downward. So it's not accelerating, so there is no net force. No net force, that means the two forces, they balance one another. What are the two forces that balance one another? This is the one, the tension and the weight. So we say that the tension is equals to the weight of the object. So this is the first case, very simple, object hanging downwards. So we say that the tension is equal to the weight of the object. Okay, so the second case. Now the second case is actually similar to our object inside the leaf, similar to the object inside the leaf.
Okay.
We have learned earlier, right? But now instead of resting on the floor of the leaf, and we look at the normal reaction of the leaf on the object is now attached to a string. The string is hang on the ceiling of the lift. Is hang on the ceiling of the lift. So it is something like this. But they draw too many arrows there. So many arrows. Okay. But actually you don't have to worry about all the so many arrows. There are only actually two arrows acting on this object. So this one we transfer down here, transfer down here, right? Okay, actually it's like the first case, it's like our first case. The object is hanging on the ceiling of the lift. There are two forces acting on the object. One is the tension in the rope or the string that is hanging the object. And the second force is the mass of the object. So these two forces. Hello? Ah,对。我agak 12點較淡薄，我較來。來嘅時候我 call 咯。OK，OK，OK，拜拜。Okay, so now, where are we now? Okay, here there are two forces acting on the object. One is the tension that is pulling it upwards, and another is the weight that is acting downwards. However, there is a difference between this case and the first case here. In the first case, the object is in equilibrium. The object is not accelerating. In the second case, the object is attached to the ceiling of the lift, and the lift is accelerating upwards. So that means it is moving. There is a net force acting on this object. The net force is not zero. In the first case, not moving, the net force is zero. Second case, same pair of forces acting on the object, but the object is moving. There is a net force. The net force is not equal to zero. Okay, now I would like to ask you, if this object is accelerating upwards, which of the two forces is bigger? The tension is bigger or the weight is bigger? The result is it is moving upwards. The thing is moving up. Which one is bigger? T bigger or the mg bigger? What is your answer?
Think T, right?
Yes, correct. T is bigger because let's say the T and the mg, who will win? Let's say in the tug of war lah, the thing is moving in the direction of T. So tug of war, if it's moving in the direction of T, means T wins. If T wins, that means T must be bigger. So if T is bigger, I have to use T minus mg. So this is it. So the net force is actually T minus mg. Why T minus mg? Because T is bigger. Because it's moving upward, T wins. T is bigger. So the net force is T minus mg. Well, what is the net force? Net force, according to Newton's second law of motion, it is equals to ma. So I replace the net force with ma. So ma equals to T minus mg. So if I want to find the tension in the string, I make the T the subject of the formula. When I make T the subject of the formula, the mg, you move over to the other side, becomes mg plus ma. So our conclusion is, if the object is moving upwards, the tension in the string is much bigger than when it is stationary. Because not only you are holding the object, you must pull the object upwards some more. So you need a bigger tension, right? Any questions so far?
No.
No. No, then we stop here.
Okay.
But there are two more cases involving the tension in the string.
Okay.
Both of them now in equilibrium lah. This one not worry so much. There's no net force. Net force is zero. Only this one we worry about the tension in the string. Then we do some numerical examples, meaning we have numbers lah. Work out the tension in numbers, right? Okay, that's all for today. Right.
See you next Saturday, sir.
Yeah, see you then. Thank
you.
you.